Okay, welcome to LendAPI Academy. All right, today we're going to walk through pricing engine. Let's start by prefacing what pricing engine actually does. So LendAPI has a pricing engine tool. It operates in effectively two facilities. One is it allows for the um, builder to be able to configure a offer table, to be able to map things like terms, conditions, and other instances. The other is, I view it simply as almost a data server. It's a SQL server, if you will. It allows for the user to be able to retrieve certain data and map certain attributes. So if you are a lender that has a large set of attributes or a large array of data that you want to map to a certain variable, this is the Blend API solution to do so. And to get started, there's really only two components you have to understand. One is to start, one goes in to create a pricing engine itself. So when you navigate to the pricing engine feature, you go in and you can start the pricing engine module. There's two sets of pricing engines. Or two sets of engine type. One is a parent and one is a child. The biggest difference between a parent and a child is a parent pricing engine operates almost independently. It allows for you to have a set of inputs and then have one set of outcomes. A child is a little bit different. A child pricing engine actually feeds off of the parent. So at LendAPI, we have the idea of a nested rule where a parent rule can then trigger a child rule. The pricing engine operates the same way. A parent pricing engine can actually trigger a child engine downstream. So this would be your main trigger. And instead of an outcome or a rule to trigger another pricing engine, you can actually trigger it directly from the parent engine. So this feeds in as the input to the child. So let's start with a simple parent engine today. And we're going to go through and put in an auto pay offer table. And once you create it, you're going to see this particular canvas to start working through. So a couple notes to understand. When you are inside of the LendAPI pricing engine, the first thing you'll see here is the actual canvas for you to view all the data. And then here are the controls for how the data is going to be interacting with the actual platform itself. So to get started, the user actually needs to upload a Excel, and it has to be an Excel file. It cannot be anything else. If you're completely new to the pricing engine, LendAPI does offer a sample offer table for you to start playing around with. And you'll see once you open it, I will have to go through and open it on a different platform. Okay, 1 second. So when you go and open this in a different platform, this is a more structured one than what's actually shown. But a couple things to note is the first column is going to be your header column. So here you will allow you to actually set, we call them operators, but they are actually, you can think of them as, you can think of them as like anchor points inside of a table. It basically tells the platform where to start to read the Excel table. It starts at cell 1A and then goes down and reads header and reads operator. It's basically telling, okay, so this is the header column and these are the operators. And from there, the platform will then know, okay, then I'm going to start on cell 1 or A4 to understand what the first row of data is going to be. So this is really your control column, if you will, within the pricing engine. And it tells the platform basically how to operate. So here, the header are going to be these different naming structures that you put out here. And then the operators are going to be the actual, they're effectively the logic within the pricing engine, whether it's an absolute equal or range or empty. So this is effectively how we would manage a LendAPI pricing engine. Below that are actually naming structures within the actual pricing engine itself. You'll notice that with LendAPI, there's a name or a code for everything you do. Whatever you create within LendAPI has to have a code associated with it. That's how the platform retrieves information. Everything needs to be stored in either a code or a name. So, though this may not have a lot of significance in the end result, it is crucial in actually making the pricing engine work in this instance. And then from there, we're going to talk about a few different actual systems within the pricing engine. The first is what is called a condition. So a condition is exactly what it sounds like. A condition is, if you think through any sort of logic in any sort of language out there, there are going to be conditions, and that's exactly what LendAPI operates as well. So you can have as many conditions as you want for any set of pricing engine. They're going to be two sets of operators when it comes to a condition. There's going to be an equal sign, which basically indicates an absolute value. And then there's going to be a range. So you'll see here that the equal sign can be given to both a string variable or a numeric variable. And this equal sign basically indicates that for this condition 1, in order to get the outcome, it has to equal this exact variable type, meaning primary residence. It has to be verbatim for this condition to be met. Condition 2 is also equal sign. And you'll see here that there are variations, but the logic still stands. For a user to have this outcome, this exact condition for units has to be met verbatim. And range is a little bit different. Range in itself can only be used for numeric variables inside of LendAPI. So range, again, is exactly what it sounds like. Range falls somewhere in between two numbers, effectively. So in this instance, the max loan amount for condition 3 is operated on a range, meaning it has to fall in between 150,000 to 1 million. And there's a little bit of a caveat when using range within LendAPI. The way that the platform reads a range is it starts at the bottom number. This is kind of your base. And then it goes up to here, but it actually does not read the 1 million number. So if you say your range is 150,000 to 1 million, the platform actually only reads it as 150,000 to $999,099. So it never actually reads the upper echelon. So if you do want 1 million to fall within range, the upper echelon actually has to be 1,000,001. So here, what I'm telling the platform to do is the range is going to be greater than or equal to 150,000 up to 1 million. And then if it reaches 1,000,001, it's out of range. So that's generally how it works within this platform. So when you set your range, just be very careful on the max number on the upper echelon, because it's whatever you set should actually be 1 or 0.1 above where you actually want the number to land. And then, of course, if you don't have an upper echelon, here's another way to read range. You can leverage the plus sign here. So you'll see condition 6 is actually a range for our FICO, and it's say 660 plus. And basically what you're telling the platform is that it is a minimum of 660, but there is no upper echelon. So it can go up as much as possible. It just has to meet the bottom base number here. So these are all of the criteria to set a condition within the pricing engine Excel. Now, you'll notice that there's one other column here, and this is your outcome or your action column. So action column within the pricing engine is in fact an outcome, and it's usually tied to a system output variable, or I should say it's always tied to a system output variable. And the way it operates is this is the actual variable that gets spit out at the end of the pricing engine based on all of the conditions that are met. This particular variable, in effective, is what you are setting this pricing engine up for, right? You're setting up all these conditions to basically query this outcome. And generally speaking, that's exactly what you want these offer tables to operate on. So you have conditions 1 through 6. If any one of these are met, then the outcome for this loan is going to be an approve. If none of these are met, then the outcome will probably be a null in this case, or sometimes a decline. So the logic here is pretty simple. Outcome, you'll see, doesn't have an operator. The reason for that is because there is just absolutes for outcomes. It either is or isn't in this case. The header is still important for this action item. So you can name it based on what makes most sense for your specific pricing engine, whether it's outcomes, approvals, terms, frequencies, whatever that be. But in this case, you don't actually have to set an operator. The platform itself will see this header as action one will and know that this is an output variable and not an input variable. Now, there's one more header type that's not shown inside of this particular sample, and that is actually called a derived variable. And a derived variable is generally used as an action more so than an input. And the way that generally works is a user can set a set of calculations in a derived variable to generate an output from it. So let me show you an example of a set of derived variables that was created. So here we've created a set of pricing engines and with our conditions and our actions. And what you'll see here is we have actually 4 sets of derived variables at the end. And you'll notice that like the action items, the derived variables don't actually have any operators because again, they're absolutes. They are a calculation. So if you meet this condition, what's going to happen is the pricing engine will take these variables and actually calculate. This looks like an PMT calculation and spit out a number at the end. Same with these and these. So in this case, we are looking at certain FICO scores, DTIs, and terms. If these are met, then, FICO scores and DTIs. And if these two are met within certain range, then these actions will be set as outputs, and these derived variables will also be calculated and shown to the user. One quick caveat to note when you are setting a derived variable within the pricing engine, you'll notice that there is certain variables actually tied in here, things like interest rate or cart total. These two are very specific. One, they can be called based on the actual variable that's either coming in from a outcome or an input variable. So in this case, cart total is actually coming from a condition. And it is, in this case, actually coming from the user input or an outside source itself. And I've labeled this as cart underscore total in my variable, in my user input variable as code. So I'm actually telling the pricing engine that when you get to this particular cell, look for this variable in LendAPI, retrieve the data, and then utilize it to actually do the calculation here. The same thing with interest rate. There's a variable in my model studio called interest underscore rate, and that is utilized to do the calculation here. To actually initialize this particular calculation in the pricing engine, these two variables have to be added as actual columns within the pricing engine, meaning they have to be initialized somewhere within the pricing engine. It can be a condition or it can be an action. Does not matter, but it has to live somewhere inside of this Excel file. You'll see here that cart total here is actually a condition. And because it's user input, there's going to be variations of this. So I didn't have it as a range or an absolute equal, but I did have it in here as condition. That way I can map it back to the pricing engine itself. And then interest rate is an action. It is going to be called based on the condition, but it is also in here. And that way I can map it back when I put this particular table back into the pricing engine. And This gives this derived variable or this derived calculation something to tie back to. So, if you're actually interested in what all the calculations are supported within the pricing engine for derived variables, you can actually find that inside of our LendAPI derived variable. And there is an actual calculation dictionary in there. It tells you what's all supported and how to actually write out certain things like exponentials and derivatives and whatnot. So there is a dictionary tied to it if you're interested. And then the last thing to note is that generally speaking, derived variables are an output. They can be used as an input to a child pricing engine, but if you're setting up your own independent pricing engine, a derived variable is going to be mandated as an output variable. So it does give you more flexibility in how you calculate things like interest rates or terms or amortized loan. Cool. All right. I think we are at time today, so I'm going to stop here.